Nelson is a research scientist for the Canadian Wood Fibre Centre of Natural Resources Canada. He graduated from Laval University with a Bachelor of Science in 1998 and with a PhD in 2003. He works mainly on problems related to regeneration silviculture, having interests spanning across reforestation, ecophysiology, nutrition, and ecology. Nelson is an associate editor for the Canadian Journal of Forest Research since 2005 and was associate editor for the New Forest between 2005 and 2020. He's an adjunct professor in 4 universities in Quebec and Ontario, and he is co-leading the Quebec Network on Reforestation and Intensive Silviculture, an innovation network of researchers and end users that focuses on reforestation under its many forms. Sounds like he'd be the perfect guy to ask a lot of smart questions of. And with that, I'll pass it over to Nelson. Thanks.
Hey, thank you, Andrew. I think I've succeeded in sharing my screen. So thank you very much for inviting me today. I'm both humbled and honored to be on a panel with Milo and all the others. It's so great to be with you today. So what I plan to do is first to present you a timeline with a few key points over the past 40 years that help understand the actual silviculture and vegetation management strategy in Quebec. Then I will be providing you with an overview of the gradient of silviculture intensity used in Quebec. Because of my background that is exclusively in research, I will provide you with examples that are drawn from research projects I was involved over the past 2 decades. Also, although uneven age management is quite important in Quebec, I will focus mainly on even management silviculture, even age management silviculture. And at the end, I will try to identify a few issues and challenges that are related to this strategy without herbicide in the province. So hopefully I can be able to switch here. So before I go further, I want to acknowledge that I have the privilege of living and working in Quebec City, which is on a land that has been occupied over time and is still occupied by Indigenous peoples. And the closest nation here is the Huron-Wendat Nation at Wendake, about 2 kilometers from where I live. So first, here's the timeline of the past 40 years on which I've identified a few key points I think are important to understand the actual silviculture strategy in the province. I won't go through all of that, but maybe first focus on the fact that following the first formal aerial spraying program that was launched in Quebec in 1980, it was followed by an environmental commission that in Quebec we call BAP commission. So BAP means the Bureau of Public Hearings on the Environment. So the BAP looked at the toxicity and the potential problems in using specific herbicides that you see listed here. And following that commission, these specific herbicides were banned from use in Quebec and were rapidly replaced by the use of glyphosate, which has been for the following years the main way of managing vegetation in the province. And then probably the next important step was that following public concerns about the use of pesticides in forests, so including herbicides but also insecticides to treat stands that were affected by the spruce budworm outbreak of the time, the government proposed what they called a forest protection strategy that they submitted to another environmental commission of the BAP. And in this strategy, they really packaged this idea of rather than using artificial reforestation as a main way of renewing forests, the focus should be put on natural regeneration, and then there should be a gradual decrease and eventually ban on the use of chemical herbicides, and that all silviculture decisions should be based on a good understanding of the ecology of the sites. This strategy was thus submitted to the BAP and was officially tabled and adopted in 1994. So if you're looking for the point in time when the Quebec government committed to reducing and banning the use of herbicide, this is the point. This strategy was again submitted to yet another BAP commission in 1997, which looked again at all the pros and cons of the strategy that was proposed and confirmed that the government should go forward with this approach, so that in 2001 there was the official ban on the use of chemical herbicides on crown forests in Quebec, and it has been that way since then, so for the past 20 years. Maybe worth pointing that somewhere in 2004 or 5 there was the creation of the Chief Forester Office in Quebec. So the Chief Forester is responsible for all AAC calculation in the province. Then there was a new Forest Act adopted in 2013, and more recently, so in December 2020, the province adopted what they call a timber production strategy that really focuses on intensive and elite silviculture. But even in that strategy, we still see a mention that in Quebec, on crown forests, there is no use of chemical herbicides. So hopefully this timeline gives you a bit of context of what has been going on in the province. So another element of context, just to show you, this is the average harvesting that is going on in the various provinces across Canada from the National Forestry Database. So you see that in Quebec around 200,000 hectares were harvested in, this is probably from 2016 data, and that quite a lot of planting is going on, but overall, because of the forest protection strategy, the majority of harvested sites are let to regenerate naturally. So following harvesting with protection of advanced growth, about 70 to maybe 80% of the harvested sites are let to regenerate naturally. So planting occurs on 20-30% of harvested sites annually. And probably a last element of context is the ecological framework of Quebec. It is important to understand that most of the commercial forestry in the province, although a lot is occurring in southern Quebec and southeastern Quebec, most of the commercial forestry is happening in the boreal forest. And what here you see as the black spruce moss domain and the balsam fir white birch domain. And it ends up that about 3/4 of the seedlings planted every year are planted in these environments. And this has a huge impact on the strategy that follows to ensure the success of these plantations. So a few years ago with my colleague Vincent Roy, we tried to capture the vegetation / silviculture strategy of the province, and we did that with this diagram as a function of site fertility that you have here on the y-axis. So of course, following harvesting, there's an evaluation of the need for planting based on conifer stocking or preferred species stocking, and then evaluation for the need of site preparation. That can be driven either by the need to control some competing vegetation species or also the thickness of the humus layer. And then as a function of this fertility gradient, the choice of stock type will be made from using very small stock seedlings for sites that are less fertile, which comes with a given type of competition complex, up to standard, medium, and large stock seedlings for sites with high fertility that are usually dominated by very aggressive competing species. And then the need for the manual release treatment will come in at different place and time, depending again on this site fertility gradient. So you see at the bottom of this gradient, most sites won't need any release treatment, but on most fertile sites, a first manual release might be needed very soon, and then might need to be followed by the second release and even a cleaning or pre-commercial thinning later. So this graph captures pretty well, we think, the actual vegetation management strategy in place in the province. So talking about these competition complex, as I said, most of the commercial forestry is happening in the boreal forest. And what you see here is the distribution, the relative abundance of one very important species in these ecosystems, so Kalmia angustifolia, which is an ericaceous shrub that rapidly comes to dominate some sites in the boreal forest. So following harvesting, sites that are prone to Kalmia invasion will look like what you see on the top right or at the bottom right of your screen. So these species are a very strong competitor for soil resources. So they don't really compete for light. They compete for soil nutrients, and they have different mechanisms. Research has identified different mechanisms responsible for stagnant seedling growth when sites are dominated by these species. Another related species is bog Labrador tea, which is also typical of the boreal forest that we can find following harvesting, but also following wildfires, such as in this case. So you see this is about a year or two following the fire, and you can clearly see that these seedlings are taking over, and any conifer that could regenerate on those sites will be hinder in their growth because of these species. So at the very bottom of the intensity gradient of silviculture, there's this idea of harvesting and letting natural regeneration be responsible for forest renewal. There are, as for Alberta, there are some regeneration standards that must be met to declare that a site does not need to be replanted. The threshold is usually around 60% of conifer stocking. So above 60, usually the site is considered as regenerated. Below 40%, usually it's a no-brainer, and any harvesting is followed by artificial reforestation. But between 40 and 60, this is a gray zone. So a few years ago, we go and revisited a bunch of sites that had been evaluated shortly following harvesting, and what we've observed is that the evolution of conifer stocking is really dependent upon the type of competing vegetation coming back. So these codes that you see on the right, they refer to either light intolerant hardwood cover, medium ericaceous shrub cover, and so on. So all that to say that depending on the vegetation complex and on the site, there might be some cases where poorly stocked site will grow a inadequate conifer regeneration strata, whereas other will really need to be treated using artificial regeneration methods. So going up in this gradient of silviculture, when the conifer stocking is not high enough, then foresters will rely upon plantation that is most of the time in the boreal forest, that most of the time follows mechanical site preparation using equipment such as the one you see here, the Brachy T26. A few years ago, we did some studies to look at what was the real impact of these mechanical site preparation treatment on seedling growth. And this is one example among many that we've published, in which we have shown that combinations of mechanical site preparation treatments of different intensity with or without fertilization at the time of planting can have a very significant impact on seedling growth following plantation. So to give you an idea, about 65,000 hectares hectares are mechanically site prepared in Quebec every year. Fertilization, not so much. This is not a treatment that is used unless in very intensive and elite silviculture scenarios, but not in the boreal forest. So we revisited those sites a few years ago, and these are recently published results. 18 years following planting, we still observe this very significant impact on mechanical site preparation, on seedling dimensions, but also on seedling growth. So the seedlings that were planted on mechanically prepared site are still growing faster than the seedlings planted in control plots. Now, if we move more to the southern type of ecosystems in Quebec, these are dominated by completely other species. Of course, all of you probably know about red raspberry, which is a very strong competitor for light and nutrients, but also pin cherry, another very important competitor in southern and central Quebec. In the picture on the right, you see someone standing in one of my experimental sites, and these are control plots. This is a control plot after the during the third growing season following harvesting, and it's all invaded by pin cherry. So for these kind of sites comes in this strategy I was describing at the beginning. So early planting following harvesting to take advantage of this competition-free period, using large stock seedlings, either produced as bare root stock seedlings or containerized stock seedlings. I must admit here that although bare root seedlings are still produced and planted, they account for a very small proportion of the number of seedlings outplanted every year. So most of the medium and large stock seedlings that are used on crown forests, at least, are produced in containers. So these seedlings can be 35, 40, 45 centimeters in height. And they have a root log that can vary between 200 to 350 cubic centimeters each. And following planting, the decision to perform manual release is based on light availability at the seedling level using septometers, as you see on the left, and then sites will be manually brushed as often as needed by the competing vegetation that is invading the site. So here's an example of the research we've done over the past years to see if this can really work. And what you see here is the seedling size. If you look at the right, you see DBH after 11 years. And 3 different environments. So a control with with vegetation, so meaning no vegetation control. And in green, you see a complete control of vegetation. So this represents the real site potential for this species. And you see that by using large stock seedlings planted early following planting and with mechanical release applied at the right time, we can reach up to 88% of full site potential. So this is a demonstration that this strategy can work when it is applied correctly. And now at the end of this intensity gradient, we have elite silviculture, so the planting of fast-growing species. For example, here, hybrid poplar that is usually planted, depending on the region, following very intensive mechanical site preparation. You see on the top right. So this is V-blading, very intensive at the site level. So we decided to see, is there a way to maybe be quite intensive but on a smaller scale and obtain the same kind of response, still not using chemical herbicides. And we've demonstrated that mounding followed by planting without any chemical herbicide use can lead to quite interesting growth. So these are results for height and DBH of hybrid poplar 4 years following planting. We also looked at how mechanical site preparation, in that case mounding, site prep, can be used along with mechanical release at following different scenarios to promote the growth of hybrid larch, so have fast-growing conifer species that is also planted in the province. And again, we've shown that by following the right scenario and the proper mechanical site preparation treatment, the growth can be quite interesting for this species as well. So this gives you a very, very high level idea of the type of silviculture that is carried out in Quebec without herbicide. Now, a few years ago, we tried to understand what are the issues that can be related to intensive scenarios such as the one I just presented at last in the context of ecosystem-based management, because one has to understand that within the Forest Act, in the very first paragraph, it says that ecosystem management is the founding paradigm that must underlie all forestry going on in the province, even in the most intensive scenarios. So here you have a list of the few issues that need to be taken into account when doing this kind of silviculture. To those, I would like to add the invasion by exotic invasive species such as glossy buckthorn. This is a weed that is invading Quebec forests right now, and to my knowledge, chemical herbicides are about the only way to effectively deal with such a species. Another issue is the need for a very tight follow-up schedule when using these non-herbicide scenarios. So the results that I've shown you are based on research context, but in an operational context, it's quite a challenge to make sure that all plantations are visited at the right time and are treated at the right time to make sure that they provide the ecosystem services that why they were established for. So in conclusion, silviculture intensity in Quebec ranges from basic to elite, and I've provided you with a few examples of these different levels. The means that are used, the objectives, and the frequency of intervention required are the elements that define this gradient of silviculture intensity. And whatever the intensity, no herbicides are used across the public forest in Quebec. And remember that even in intensive silviculture approaches, the principles of ecosystem-based management must be met and maintained at the landscape level. So I hope you enjoyed. Please note that I will share in the chat box links to this presentation, but also to a list of the detailed references I've cited throughout this presentation. So if we have time for questions, I'll be happy to answer them. Thanks.
Thanks, Nelson. I think we do have time for a couple questions, so I'll start off. In southern Quebec, for control of raspberry and pin cherry, how many release treatments are typically needed?
Sorry for that. I'm trying to... Sorry, Andrew. Could you repeat, please?
Absolutely. In southern Quebec, for control of raspberry and pin cherry, how many release treatments are typically needed?
Okay, typically I would say at least one, and in some cases two. And so usually a first release treatment will be needed after 2 or 3 years following planting, and then a second treatment will be needed at age, for example, 9 or 10 or 11. And in Quebec, usually we distinguish these two by calling them either a release treatment at the seedling stage and then a cleaning treatment at the juvenile stage. In some extreme cases, a third treatment might be needed. So a first release after 2 years and then a second release after 4 years. And sometimes, again, another one at age 12 or 14 or 15. But it all depends on site fertility.
Excellent. And we'll ask one more question. What percentage of sites in Quebec will have manual release treatments?
Oh, that's a very good question. Unfortunately, I cannot answer that from the top of my head. I would have to go through the statistics of silviculture in Quebec, and we could look at the number of hectares that are planted every year, and then we have the numbers of hectares that are subjected to manual release, and we would have a pretty clear figure of that. But unfortunately, I cannot provide you with a correct answer from the top of my head. I'm sorry.
All right. Thanks a lot for your time today, Nelson. It was
My
great
pleasure.
hearing from you, and it's good to hear what's going on in Quebec.
Thanks.
Thank you.